Today I'm going to talk about SRISK. So the starting point of SRISK is a paper that was written by Acharya and some co-authored at the NYU Department of Finance. And the central element of this model proposed by Acharya, which is in a way very intuitive these days, is that the capital shortages of financial institutions can generate systemic risk when these capital shortages occur when the economy is in distress. Okay? So the argument is that in normal times, if a financial firm experiences a capital shortage or defaults, this firm can be, this firm could default or could be bought by some other institution. Distress of an individual company when you're in normal situations shouldn't be a big concern. The problem is when these capital shortages occur in period in which the economy is distressed as a whole, because first of all, we have empirical evidence, and it kind of makes sense that if the economy is distressed, we're going to observe multiple distressed institutions at the same time. Okay, so we're not just going to have a random failure, but we might have clusters of failures. On top of it, firms that might not be under distress might not be willing to take over other large institutions that are having issues during a crisis. So, as we were saying yesterday, the capital shortage of the firm and the distress of the firm could just be resolved with either that firm going bust or that firm being bailed out by the system. But none of these two options, if you think about it, is really that appealing, because the firm goes bust, as it happened with Lehman, that might have spillover kind of negative repercussions to the rest of the economy. And again, as I said also yesterday, bailing out that institution, again, might not be kind of the most, might not necessarily a good thing, because essentially we're just kind of transferring the problem from the financial system to the taxpayers. So what Acharya and co-authors did in this paper, they introduced a measure of systemic risk which stemmed out a small structural model that these guys wrote. And what happens in this model is that essentially the capital shortage of financial firms depends on the degree of leverage of firms and a parameter called marginal expected shortfall that can be thought of essentially as a downside beta. Okay? I'll give you the formal definition in a little bit. And this model is kind of nice, but it wasn't really kind of something that you could work with. In a way, the paper is called Measurement of Systemic Risk, this paper here by Acharya, but in a way, it's kind of more a theoretical model. Like they have estimation results over systemic risk measure, but they could only estimate a systemic risk measure after they observe the crisis. So, ex ante, it's unclear how useful it is. So what we did while I was at NYU is that I worked with my advisor at the time to try to, kind of refine the methodology and the index in a way. Now, I don't know if I'm going to be able to show it, but actually we have a website that has a bit of a tricky name. It's called the VLab. It's the Volatility Lab, in which we provide on a daily basis we provide on a daily basis systemic risk indices for different types of financial firms. And in this site, we also, so here I'm just going to talk about US institutions, but in the website, we actually cover, we have a big panel of institutions covering pretty much the whole world. Will be interesting. So for instance, I think, if I don't recall correctly, I think BNP Paribas, for instance, is one of the top systemic risk institutions according to this criteria. If you look at the latest rankings, and you can browse stuff and see what's going on as of now. Okay, so starting point of this. So what we do in this paper is that we have a very simple measurement approach to come up with a measure of the capital shortage a firm is going to experience in case of distress. Okay, it's a very simple model. Let me show you how this works. So what we do is that we begin by defining this variable called CB, capital buffer, IT. So this is the capital buffer of financial institution I on day T. And this capital buffer is defined as the difference between the market value of equity, which is denoted by W, and minus a certain percentage, denoted by K. So K, if you can think of a percentage, say 8%, of the quasi-market value of assets. Okay, so what's the quasi-market value of assets? So we measure assets using the book value of debt and the market value of equity. So the point here is that we are assuming that financial institutions, because of prudential regulation, sorry, because of prudential management or because of regulation, need to hold a certain percentage over total assets. Okay, this is a kind of a reserve that cannot be used. So in practice, the actual capital buffer that firms need to use for their day-to-day operation is the difference between this quantity, the amount of money that they cannot spend because that's what they want to do just to be on the safe side, or because laws require you not to spend that amount of money, and the market value of equity that you have. Now, when this variable, the capital buffer, is positive, you're good to go, you're happy because you have enough money to do your day-to-day stuff. When this variable becomes negative, then you have a problem because you're going to be capitally constrained, and that's going to be a distressful state in a way for a financial institution. So what we do here, and in a way it's very simple, we're concerned with predicting what's the degree of capital shortage that a financial firm is going to experience conditional on some systemic event happening. So what we do, is I like to think it's quite straightforward, we compute the expected value of the capital buffer that a firm is going to experience over the next 6 months, conditionally on knowing that over the next 6 months we are going to observe a systemic event. Okay? So what we do in the paper, we define a systemic event as the market losing losing more than 40% than its value over a 6 months period. These are just tuning parameters. We could discuss if you want to do 3 months or different threshold losses. Okay, so that's something that you have to choose, so to speak. I will not discuss how you would choose this in practice. And what we do is that we compute the expected capital shortage that the financial firm is going to experience, as I said, from now to 6 months in the future, conditional on the market having this large depreciation. Okay? So I'm not going to go through the computations. These are very straightforward computations. Again, we have a very simple model, so we essentially assume that in case of a market downturn, the book value of debt cannot be renegotiated. So this implies that the expected value of the debt of the firm, given a substantial market contraction, is equal to the value of debt today. So the only thing that will change in case of a crisis, and it's going to become much smaller, is the market value of equity. So you do straightforward computations, and you get that the expected capital shortage in case of a systemic event is going to be given by this expression over here. Now, I'm going to comment what this is. So what is this? So this is equal to WIT, so the market value of equity. So the bigger you are, the bigger is going to be your capital shortage. That kind of makes sense, right? So even if in relative terms, two financial institutions have the same reduction in equity returns, okay? If one firm is going to be larger than the other one, then the capital shortage is going to be larger for the larger institution. Then this thing depends on leverage. So the more levered you are, the larger is going to be your capital shortage. And then finally, it depends on this parameter. This also shows up in the Acharya paper, the MES. This MES, it's simply defined. So I have another slide about this quantity later, but it's essentially this parameter over here. The MES is simply the expected value of the market returns, of the returns of the financial institution I from tomorrow until 6 months in the future, conditional on the market being conditional on the market losing more than let's say 40% over 6 months. Okay, so it's simply a conditional expectation to what's going to happen to the firm, given that we know that we're going to have a systemic event. So this index over here you can interpret as essentially as a prediction of how much capital a financial firm is going to lose, okay, if things go bad over the next 6 months. And so the way we define our systemic risk indicator in the paper is very straightforward. We just define our SRISK indicator for firm I on DT as the value of this conditional expectation. That's it. So not particularly fancy model, just to be clear. We are using a little bit more fancy time series when it comes to compute this thing, because in a way, that's our job. The model is pretty simple, if you ask me. I don't want to be intellectually dishonest. This is kind of a very simple model, but it gets the job done to kind of get an index, the type of indexes that we wanted to construct. Now, as I said, I come from stats, so we like numbers to be pretty. So this number often is not really nice you can't really interpret it. It's the amount, the expected capital shortage a financial institution is going to experience in case of distress. So this is going to be a big number expressed in dollars, not really pretty to look at. So what we do is that we prefer to look at the percentage version of SRISK. So what we do is that we simply standardize the SRISK index without the percentage sign by the sum of all the positive SRISKs. So how do you interpret this? So the sum of all the positive SRISK can be interpreted as the sum of all the capital shortages that financial firms are going to experience in case they're going to experience a capital shortage. So, you can think of this number of, in case we decide to bail out the entire financial system because some systemic event has occurred, how much money do we have to provide to the financial system? You can think that this is the number that you have to give to, different financial institutions to make sure that they don't go bust, okay? So what we do is that we, in order to compute a number which represents the level of systemic risk for one institution, we just compute the ratio of the systemic risk capital shortage of one financial firm divided by the total amount of capital shortage of the system, okay? So this you can interpret as the proportion of capital shortage of the financial system that it's due to the fact that firm I is very vulnerable to a systemic event. So this is the number that we're going to use to rank different financial institutions. We are also interested in coming up with a number that tells us the overall degree of systemic risk in the economy. So what we do for that, we just compute the sum of all the positive risk contributions. Yes?
So if you quantify the total risk in the system, then you suppose or assume that these institutions are independent of each other. So one institution could have sufficient capital, let's say.
See, perfect. Okay, I get it. So, yes, again, this is just a measure. If I had to justify why we do that, in a way, is that I would say that if you have a crisis, it is likely that even financial institutions that do not have a problem might not be extremely healthy, so to speak. And during a crisis, these firms might not want to give money, lend money to other financial institutions that are in distress. So the idea here is that in normal times, if one firm goes under, another firm will take over or will give the capital they need. But in a crisis, maybe that's not going to be as smooth because firms are going to be concerned that if I give money to save this other bank, then I'm going to have problems too. Or I'm going to, in a way, get a piece of that. I'm going to, in a way, inherit a piece of their problems. Just one thing. So here we put the pluses just because, in a way, it makes more sense to us. When you look empirically at these numbers, I would say that these numbers tend to be like, these capital shortages tend to be negative, meaning that a financial firm is not going to experience a capital shortage for very few small institutions. So this is just to make things kind of prettier from a presentation point of view. Empirically, when you compute this kind of distress capital shortage tends to be, this distress capital shortage tends to be negative for the vast majority of institutions out there. So, well, this is just what I just said. So the percentages risk can be interpreted as the share of systemic risk of firm I, and this other SRISK index without the I is in a way, the total amount of systemic risk in the economy, according to the specific interpretation. Just one little extra detail about the MES. So MES is something that is called marginal expected shortfall. It's something that comes out from the risk management literature, and I'm not going to comment too much on that. It's just a tool that is used in the literature. And this marginal expected shortfall, it's simply the expected value of the cumulative return from T+1 to T+H for firm I, conditional on the market losing more than C from T+1 to T+H. And turns out that if you do risk management, this is a measure of sensitivity of the expected shortfall of the entire economy to distress in firm I. So this thing came before in another literature, but in a way here, we're using it in a different way, so to speak. It's just a term that we decided to call MES because that's how I call it in the risk management literature, but here it has a very different function in comparison to how this thing is used in the risk management literature. Issue here is how you estimate this stuff. Now, in a way, estimating this index is pretty easy in the sense that this thing you can get from the internet, this thing you can get from the internet. The only thing where we have to put a bit of technology is the computation of this index, MES. And as I said before, we are kind of time series guys, and so we put a bit of technology into this because that's what pays our rent in a way. But I'm not going to talk too much about it because it's not the most exciting thing. But let me just point out what we do. So what we do is that we specify a bivariate model for the returns of firm I and the returns on the market. And what this model says is that given the past, this pair of returns has a distribution with mean zero and covariance matrix given by this matrix over here. And this distribution can be arbitrary. So I'm using D to say that we are not specifying the distribution, okay? And what we do in the paper is that we have a way of estimating the variance terms that appear in this covariance matrix and the correlation between the two series of returns, as well as also estimating the distribution. So in a way, we have kind of a non-parametric approach in which we allow for time-varying covariances, time-varying correlation, arbitrary distribution between this pair of returns. In particular, if you're we were talking to Danilo, which is somewhere here. He's been working on GARCH. We're a big fan of GARCH. So essentially, we use the TARCH model for the volatility model and a model called DCC for the correlation. These are really standard models used in risk management for modeling time-varying volatility and correlations over time. So I have the equations. I'm not going to talk too much about them, but it's really kind of straightforward technology that has been around for, I would say, 10 years. Well, the GARCH has been around for 30 years. The DCC has been around now for 15 years, so very standard stuff. So here I have the equations of how the variance changes over time, and here about the DCC, but I'm not going to talk about it because it's just too boring. And once you estimate these models, it is quite straightforward to cook up an estimator of MES based on the parameter estimates that you get from the model. And we have different ways of estimating the MES in the paper. Here I'm just reporting one of the various estimators we have. This, in a way, it's kind of the easiest estimator to compute. So it turns out that you can compute MES as the product of three quantities. The square root of the forecast horizon. So I was telling you a loss of 40% over 6 months. So, the square root of H will be square root of the number of days in 6 months. Then this beta IT plus 1, this is an estimate of the regression coefficient that you get if you regress the return of bank I on the return on the market implied by our model. So since in our model volatilities and correlations change over time, we are able to essentially back out time-varying estimates of the degree of dependence between these between this series of returns. And then the last ingredient is ES. Now, ES stands for expected shortfall. It's a standard measure of risk management used in the literature. And essentially, this is just the expected shortfall of the market, again, computed using the estimation results that are implied by the model. So essentially what this formula is telling you is that the marginal expected shortfall, so how much the stock it's going to lose over 6 months if the market goes down, is equal to this number, which tells you how much the market is going to go down if the market goes down by more than 40% over 6 months, the beta coefficient that you will get if you regress stock I on the market, and the forecast horizon. Okay, so the ingredients kind of make sense. Okay. So not going to talk about this stuff anymore. Let me just show you what kind of empirical evidence we get. So what we do in the paper, then we have other analysis in which we analyze a larger set of banks, in which we also look at European banks and Asian banks, Russian banks, and these are on the website. What we do in the paper here, we just analyze a panel of large US financial firms. So we get all the US financial firms with a market capitalization larger than, I believe, 7 billion, but I might be wrong, as of July 2007. And we do a monthly analysis. So each month we compute new values of this SRISK measures. And actually, what I do in the paper, so as I said, for ranking purposes, on the website, we display results in which we look at what's the capital shortage that financial firms are going to experience if the market loses more than 40% over 6 months. In the empirical application, however, we choose a different type of triggering event. What we consider is a 10% market decline over a month, okay? And I will not always be able to show you results for different individual banks. So what we did here is that in some of the tables, what I'm going to do, I'm going to aggregate results by different industry groups in a way similar to what the guys in the Kovar paper did. And in particular, it's just that you get used to it. So we have 4 sub-industry groups in this set of financial firms. We have essentially depository institutions, so essentially commercial banks. Then we have insurance companies. Then we have broker-dealers. Broker-dealers are essentially the shadow banks that used to exist before the crisis. And then we have a residual category called others, but essentially the others category contains real estate. So depositories are in blue, insurance in red, broker-dealers are in black, and the others are in green. The other category, in a way, it's kind of important because Freddie and Fannie are contained inside this category. And in a way, are kind of the biggest, the most relevant members of the others category. Now, what I'm showing you here is a plot of the one step ahead MES. So as I said, I'm doing the analysis on a daily basis, monthly basis in the paper. But as a sanity check, I was just kind of curious to see whether this MES computed on a daily basis, just because we like to compute the things at the highest frequency possible, gives some insights into the degree of interdependence between these financial firms and the market. So this is the plot of the MES aggregated by different industries, computed on a daily basis from 2005 until July 2010. And in a way, I would like to think that, by looking at this plot, I'll try to convince you that, MES is doing the job it's supposed to do. It's picking up all the variation, the data that you would like this index to pick up. So this is the one step ahead MES condition on the market losing more than 2%. So this is telling you, if you know that the market is going to go down by -2, how much do you expect these other industry groups to lose over a day? So what you see here is that at the beginning of 2005, all the way until, I would say, roughly mid-July 2007, if the market lost 2, all of these different sectors would pretty much lose around 2, at least that would be your expectation. Things start heating up starting from the mid of July 2007. So remember, mid-July 2007, in a way, is the moment in which the first signal that the subprime crisis in the US was going to spill over the rest of the economy became more apparent. So you can see that there's kind of a gradual build-up. You do see that there are some kind of big spikes. So for instance, big spike over here is when Bear Stearns essentially went bust. So we like these spikes because we're picking up distress that was going on over those days. And as you can see, all of the series spike up pretty much at the, whoa, wait a second. They all spike up around this period. So this is July 2008. So this is roughly September 15, 2008. So that's, as you would expect, at the peak of the Lehman distress, the level of interdependence between this firm and the market was maximal. After that, we have more or less a gradual decline in the degree of risk. Thing I would like to point out here, this, to some extent, I don't think this evidence pertains only this type of measure, but it's something you find often when you also look at other type of measures of risk. If you ask me, could you have predicted in July 2000 and, I don't know, January 2007, the fact that if the market would have lost 2%, the financial sector at the peak of the Lehman events would have lost 8, at least in expectation, I would have said, no way I could have predicted this guy. So, I'm a bit skeptic about how far away you can predict if you just want to predict the degree of interdependence you're going to experience in distressed states of the economy. However, what's interesting to me to see, it might not be entirely clear, but if you make a cross-sectional ranking between these different sectors, you would notice that essentially for the vast majority of the sample, you would always have that. Broker-dealers were the most interdependent sectors with the market, followed by real estate, followed by a commercial bank, followed by insurance. So the cross-sectional rankings are remarkably stable. So if you wanted to point the finger at those sectors that would have been more exposed to adverse movement in the market, you would have got that right from the beginning, okay? So you cannot predict everything, so to speak, but you can predict some stuff, okay? Now, this is MES. This is just an index of interdependence with the market. You can think this at the end of the day, just like in the Kovar case, as a downside beta. And if I had to simplify the literature I work with, at the end, we're all kind of concerned with estimating downside betas, okay? But in our framework, the downside beta alone is not just a measure of systemic risk, okay? It just tells you how interdependent you are in the market, but it's not the measure of systemic risk. The measure of systemic risk that we're trying to sell you is this thing, so it's SRISK, okay? What you see here is the plot of SRISK from 2005 to 2014. This tells you the total degree of systemic risk in the economy. And what we did here to make the plot more readable is that we're using different colors to highlight the share of systemic risk in the economy held by different sub-industry groups. So again, black is broker-dealers, blue is commercial banks, red is insurance, and green is real estate. And I claim two things. So if I'm going to do it now. Like if you try to map the evolution of this graph with, let's say, anecdotal evidence of what happened during the crisis, I would claim that there's a good degree of fit. And the second thing I want to point out is that, well, we could argue over that, but as I told you, one kind of pitfall of a lot of literature on systemic risk indicators that they all look like a volatility. This does not look too much like a volatility, so it's something that we're kind of happy about. If you look at a volatility plot, volatility would not be very similar to this, but it would be quite similar in the following sense, that it was low before the crisis, it spikes up after Lehman, and then it went back to the pre-crisis level. If you look at the volatility in the crisis after the Lehman events, it would mean revert to its average level quite fast. Well, I will claim that here you see a bit of different dynamics, and in particular you do see that the level of systemic risk in the economy before and after the crisis are quite different. So, you know, we're happy about that. We were hoping that we will not propose an index of systemic risk which is correlated one in practice with volatility. So what do we see here? In non-suspect times, so to speak, 2005, so the expected capital shortage, so the most systemic industry sectors are essentially broker-dealers and real estate companies, okay? I will tell you which companies are exactly in this group in a little bit. As the crisis unfolds, what we observe, well, actually, let me tell you right away. The green guy, the green contribution essentially comes from Freddie and Fannie. And the black guys that make up for this contribution are essentially all the shadow banks that, in a way, were around before the crisis. So, for instance, we have Lehman for starters, but we also have, we have also we also have other financial institutions. I have the ranking in a second, okay? I'll give you the exact name in a second. Now, starting from 2007, what we see is that the level of systemic risk increases and its distribution changes. So we have that, in particular, we have the commercial banks become progressively big contributors to systemic risk in the economy. So essentially what happens here is that as the crisis widens, institutions such as Bank of America, Citigroup became relevant contributors of systemic risk, at least according to this metric, in this framework. The black line denotes Lehman. After the Lehman events, what you see is that the contribution of broker-dealers and the contribution of real estate becomes progressively negligible. This is because essentially, well, Lehman fails. Lots of shadow banks essentially wherever bottle went out of the market. And, you know, Freddie and Fannie were essentially nationalized, so, you know, they cease being systemic. So what you have in the aftermath of the crisis is that essentially big commercial banks and some insurance company, namely IIG, are the main contributors to systemic risk. And, you know, I could give you more comments on the time series dynamics of the series. Let me just point out that we have that, you know, after the crisis, systemic risk went down. It goes up again essentially in April 2010. That's when Greece said, remember EU, when we told you that we had money, we lied. So this is when essentially Greece revealed that there were some holes in the budget, and as you can see, it spikes up again when we have turmoil in Europe in correspondence to the sovereign debt crisis that hit in particular Spain and Italy. This is just the Herfindahl index, but not very interesting. So let me show you the actual rankings that we get. And I would claim, and by the way, of course, all of the things I'm saying so far is just anecdotal evidence in a way. I'm just giving you plots, okay? So what I have here, these are the rankings of the most systemic institutions each year from 2005 to 2012. And what I did here is that I just computed the rankings on the last day of March. So I would claim that these rankings will not look that bad in the sense that, so if you look at what happened in 2005, so in 2005 you would have classified as systemic Fannie, Freddie, Morgan Stanley, Bear Stearns, Lehman. These guys I'm happy about. Prudential, it ended up being here, but I wouldn't know if this is it's a false positive. Merrill Lynch, I'm again happy about this. Then I have other financial institutions that I would not know how to interpret. In my view, they're not systemic, but they end up being on the top 10. Now, this is just the top 10, but notice that if you look at magnitudes, Freddie and Fannie alone account for more than 50% of the entire systemic risk in the economy according to this measure. So essentially, you see that the systemic risk is really concentrated in a very few agents in 2005. Now, if you move forward in time, what you see is that guys that tend to be in the top 10 tend to persist in the top 10. Notice that as time goes by, starting from 2008, we have that big commercial banks start going on top. So we have Citigroup, for instance, that in Q1 28 is one of the most systemic institutions. And what happens as time goes by is that essentially some of the initial, in a way, culprits of systemic risk in the economy go out of business. So as I said, Freddie and Fannie are nationalized, Lehman goes bust. And so what we have in the top 10 is that after the Lehman event is that essentially the top 10 is dominated by big commercial banks and insurance companies. In particular, the guys that ended up being on the top 10 for most of the time, which mostly would make sense, I would say, are Citigroup, Bank of America, JP Morgan, Wells Fargo, and AIG. So qualitatively, these would not look like the worst rankings ever. Again, let me point out that you will get these kind of rankings that make some sense as early as 2005 Q1, okay? Again, anecdotal evidence, no p-values yet, but just to kind of give you a feeling of what kind of fitting results you will get if you try to fit this technique. Let me just show you one evaluation exercise that I did here, and then I'm going to talk a little bit more generally on how you evaluate systemic risk. One thing that keeps me awake at night is that how do we evaluate this stuff? So, when you do risk management, in a way, your life is kind of easy because in risk management, when you want to evaluate all these kind of different risk measures are typically moments of the data. So you can check whether your predicted moments of the data matches the actual moments of the data. Okay, so for instance, in risk management, I'm simplifying, but let's say essentially one of the key ingredients for doing risk management is volatility. Okay, volatility is the standard deviation of returns. We can check whether my predicted volatility is close to the standard deviation of returns. When you go to systemic risk and you ask me what kind of parameter systemic risk is, I have no idea. And so not only systemic risk definition implies that the object of interest is something that is not really well defined, but everyone defines systemic risk in a slightly different way. So I cannot really compare COVAR with SRISK because it's like comparing pears and apples. So that's a bit something that I find a bit surprising. So we have to be a little bit creative on how we compare stuff. Let me show here one type of exercise for validating these type of predictions. I have another one that I'm going to talk later. I'm going to make some other remarks on some historical analysis we've done that, however, because of time, I don't have the time to explain. So what we did as a first exercise is the following thing. So Bloomberg, so basically the the New York Fed, so a number of capital injection programs were carried out by the New York Fed to essentially help out the financial system that was under distress. And this data was essentially not really available, but then Bloomberg sued the New York Fed and they managed to get the data out. So it was basically New York Fed initially wanted to hide a little bit how much money we're actually giving to the financial system. So what we did is the following. We use the amount of money the New York Fed gave to different banks during the financial crisis as a proxy of the capital needs in case of distress of a financial institution. And then the question is, does the measure of SRISK computed ex ante predict how much money these banks ended up asking to the Fed in order not to go bust, okay? Now, it's important to say that this is not really, if we want to go into the details, this is not a perfect proxy. A number of issues that this proxy has. For instance, it turns out that if the CEO, so the Fed was reluctant to give money to financial institutions that essentially have very high pays to CEO. And another problem that this has, just a second, is that, for instance, these are essentially loans that the Fed provided at very low interest rates. And what happened, State Street is the bank that did this, some banks borrowed money at very low interest rates. These guys have no problem whatsoever. They just reinvested it at a higher interest rate and then gave the money back. Okay, so the Fed regulation had some rules according to which you could apply or not. So all banks that could apply applied. Some of the banks that applied had no problems whatsoever, but since we fit the criteria, they took advantage of this opportunity. Yes, sorry, I apologize.
No worries, but very interesting. But in my memory, the main capital injection mechanism was TARP. Is this TARP or is this something else?
So basically, there were 4 capital programs,
yes,
and TARP is one of them.
Okay, so you have all the data on TARP, but all the rest.
Yeah.
So what is the other stuff then?
Sorry?
What are the other channels or programs?
So, I don't know how to say, I don't know in a nice way, but...
Okay, but so the TARP was really capital, right? But so
yeah,
apparently there's also other things that not really capital or related to capital.
So my understanding, I should know this, I apologize. So basically, there were smaller programs that were implemented before TARP. So TARP was the really big one. But the New York Fed started giving money earlier on than TARP.
Yes.
And, so there's a very nice paper that got published in a journal of Review of Financial Studies in 2012, in which we analyzed to which banks the Fed was providing capital. And so what they did is that they essentially used the same data set and they merged the data set all together. I don't remember the economic rationale, but they said essentially you can consider this as different instances of the same program. So they just merged the data all together.
Okay.
But
is this data publicly available?
Yeah. So
because the TARP data I know we can find easily, but it's just like TARP and other programs, right?
No. So this is super easy. Basically, the New York Fed, I don't know how, but they didn't want to release this data.
Yeah.
Then Bloomberg, I don't know if sue is the right word, but Bloomberg sued them. And then the New York Fed was forced to release the data. And so it's a big Excel sheet. And in this Excel sheet, you can see at each point in time how much
and is it on the website of New York Fed?
I think I found it from Bloomberg after I Googled it, from some Bloomberg website.
Okay.
I have the data, so I can send you the link.
Pretty cool. Yeah.
But so TARP is the main one, but there are other smaller ones that were there too. So let me just show you a scatter plot just to give you an idea. Again, just a scatter plot. So this is SRISK as of March 2007, and this is how much money these banks got. Okay, so as you can see, again, this is just a scatter plot. Okay, correlation is very high. So as you can see, it is indeed true that firms that had a pretty high SRISK in dollar term ended up also requiring getting a big capital injection from the Fed. You have to be a little bit careful because, for instance, State Street is a guy that essentially tricked the system to make money out of these kind of loans. Interestingly, it doesn't have a high SRISK because it wasn't that risky, but of course we got a lot of money out. So of course, when you run the regression, we have to be a little bit careful. Here we just did, we didn't feel too hard about identification here. I just want to be honest. It's more of a sanity check. So these are some of the regression results we got just to give you some ideas. So we regress the Fed capital injection. We do a Tobit regression because not all banks got money here. So Tobit would be the way to go here. We have fixed effects for different industry size. We have size as risk, and we have another measure of systemic risk called SES. Punchline here is that definitely size matters. And when you look at the evaluation of a systemic risk measure, no matter what you do, there's always a too big to fail too big to fail factor. These big banks in crisis times are the ones you should be more worried about. However, on top of that, we find that SRISK is significant. We have other regressions in which we add other things such as volatility, leverage, have more extended regression analysis. And I would say that SRISK survives decently to a reasonably large set of controls. Yes?
I find it very interesting, but so my question would be, these programs were oriented to more institutions than institutions that are quoted. There are a lot of non-quoted institutions that got TARP. So this regression shows that for the quoted ones, and probably the rather bigger ones, there's a relation between getting a bailout and SRISK, right?
Yeah.
That's how we should understand this.
But I mean, for the US data, I think that all of the big financial institutions that you would like to monitor would be traded. Like
Yeah, but TARP also went to a lot of small ones, actually. So there's many more that got TARP than the ones you show here.
Yeah. But so when you look at the data,
Yeah.
don't ask me why, I found McDonald's.
Yeah. So, but actually, you will also have Chrysler and General Motors and stuff.
So General Motors, okay.
So it's more than just banks.
So, and do you know why I found McDonald's? Because that's something I just ignored and I said, I don't want to know. I don't want to know. The data is okay.
So I think what they did is they dished out money to all companies that were either systemically important, or so they defined systemically important not only financially but also with respect to employment. And so companies that were in trouble and had a lot of employment, like General Motors, also got money.
I see. Because what we did here is that so here I'm using the data on TARP on the financial institutions I am looking at.
Yeah.
Okay, so I'm conditioning on the fact that you are in my sample, and so you're big traded. But absolutely, that's a good point.
This is really interesting, actually.
Yeah. Now, let me talk. So that's what I did. Let me talk a little bit more in general about the evaluation of systemic risk indicators, and let me point out what people are doing. I don't know how satisfying you find this, but as of now, if you ask me if I can find a better reference, something cooler, I would have some problems. So, evaluation of systemic risk indicators, as I've been pointing out, is a hard job. So first of all, I think one of the major issues is that we don't have enough crises to evaluate how well we can predict what happens in a crisis. As I was implying before, systemic risk indices are typically based on different definitions, so it's hard to compare covariance risk. On top of it, if you want to take, so I like to think of these indices as just things that are defined, but then I just use them as time series, and then I try to see what properties they have. But if you want to take this series, if you want to take these indices seriously, one extra issue that you have is some of these systemic risk measures like COVAR and SRISK are prediction of what's going to happen, conditional on some set of events. So it's unclear how you can evaluate a prediction, a conditional prediction, when the conditioning event it's not realized. Okay, so that's, to be honest, if you ask me, I wouldn't know. There's some literature on doing that, but it's a bit tricky. And of course, another problem is that the sample periods that are available for evaluation of these measures are often short. So it is kind of a hard job. Let me point out a paper that got published kind of earlier on by a bunch of authors, Allen, George, and Turambali, and Bali, in which we put forward a very simple regression type analysis, predictive regression type analysis to assess what are the effects of systemic risk on the economy. So what these guys did, as I said, pretty straightforward, they just evaluated these different systemic risk indicators by essentially looking at predictive regressions at different horizons. And now this is something that is becoming quite, I would say, common to do. So as we said, typically systemic risk definitions have emphasized that there is a link between the real economy, between the financial system and the real economy, and that systemic risk in the financial system generates declines, future declines in the real economy. So what these guys propose to do is that you pick up some variables that measures real activity that you care about. So for instance, you could pick up GDP, and just run a predictive regressions in which you try to predict GDP in the future as a function of, well, we want to control for lags values of GDP, of course, lag values of your favorite systemic risk indicator, and a bunch of controls for the usual suspects. So for instance, as we said, you want to control for volatility, for instance, because we know that often systemic risk indicators are highly correlated with volatility. And the exercise that these different people do is just very interested, of course, in carrying out statistical tests on the beta to see whether beta is significant or not, and also a question is for how long this coefficient is significant. Let me just show you some evidence. So for instance, in the Turambali paper, what Turambali did is that they, again, introduced yet another index of systemic risk. They introduced an index called CATFIN, which means catastrophe in the financial sector. What they did in a way was kind of pretty straightforward. They computed valid risk, which is a standard risk management measure used in the financial industry. They computed the valid risk for the S&P 500 using different methods, and they got the average. And that's it. So, pretty straightforward in a way. And what they kind of cared about is assessing whether CATFIN had significant predictive power for predicting adverse movements in the economy. So I have the type of results that they have here. So what am I showing you here? This is a table from their paper. So here we have different forecast horizons from 1 year to 12. And this is essentially the coefficient of the CATFIN measure, okay, on different indices, indices capturing the degree of economic activity. So here you have GDP, then ADS, I don't remember. NBR is the NBR recession indicator. This is a financial stability index indicator, which is cooked up by the from the St. Louis Fed. Then we have industrial production, and then we have payroll unemployment. Evidence that you get is that even when you control for lag values of all of these variables, as well as a set of control that includes volatility, I will not give you the full list, an increase in the degree of systemic risk, at least as is captured by the CATFIN, predicts worsening macro condition. And well, it depends on which kind of indicator you get, but for instance, the result that we mention in the abstract is that you get you kind of have let's say significance up to 6-7 months ahead. Sorry, 6-7 periods ahead, which I would say it's kind of decent. Okay. Now. These guys did an interesting piece of work. These are the estimates. This is the t-stat. These are the asterisk denoting significance. And these are the r-squared. Notice that these r-squared are really very high, but that's just because they have a lot of controls. So if you see that the marginal contribution of the CATFIN index, you would see that, yes, it's significant, but we're talking about no more than 4 or 5% improvement in predictive ability. So the point I was also making yesterday. You do find that worsening systemic risk conditions, no matter how you measure them, more or less, typically they end up being good predictors of worse future conditions, but the R-square associated with these predictions tends to be not super meaningful from an economic perspective. We did the same exercise in the paper that I did with Rob. So here I just have the SRISK predictive regressions. So this is kind of similar to the stuff that Turambali has done. In particular, what we report here, so this is the F-test, this column tells you the significance of industrial production as a predictor of future industrial production at different horizons. This tells you the predictive ability of a SRISK for adverse movement in the economy at different horizons in a regression in which you do not control for anything besides lag value of industrial production. These are the same results, but now here I'm kind of including a fat set of controls, including volatility. So here, when you use this index, you would see that, again, you have predictability at medium-long horizons, and this predictability survives, at least if you look at the stars, even once you control for additional, if you control for additional series like volatility, this would be kind of the main predictor. This is for industrial production. We have similar evidence for unemployment rate. Now, this is industrial production, so this is monthly, GDP is quarterly. So again, I don't want to go into the competition of who can predict for longer, but roughly speaking, we get the same evidence in line with the paper by Turambale, which is kind of reassuring at least. And that's it.
Can
now,
I ask a question about this?
Yes.
So I find it, again, really interesting, but if I see the table you just put away...
Okay, sorry.
No, don't worry. So at the moment you introduce controls, your predictability in the short windows disappears,
yeah.
but your predict in the long windows increases.
Yeah.
Why is that?
So, okay.
So if you look at the let's say the third column of both industrial production and unemployment, and look at the F-test as risk, you see that indeed there's no stars in the beginning, but from 9 they start to show up, right?
So
what's going on?
My interpretation of this is that once we include a richer set of controls, we do a pretty good job in telling you where industrial production is moving now. So in particular, if you look at the F-test of industrial production predicted by industrial production, you see industrial production does a great job in predicting where industrial production is going to go in the next few months. But when you go a longer horizon, you don't have any predictability. This also happens if you change the systemic risk measure, you find similar evidence. So the systemic risk measure gives you predictability in the medium and the long run. But once you add kind of more controls of current status of the economy, what happens, like volatility, which volatility tends to be really kind of coincidental and indicator in a way, in a way you lose the contemporaneous predictability because the other controls do that job really well. But you still kind of have this kind of medium run predictability that tells you that, like if you see that there's a big increase in SRISK today, this is not going to help you predicting much what's going to happen tomorrow on top of the other series you have, but this is going to give you some signal on what happened 12 months from now, and 12 months from now our indicators don't really have a lot of information.
That's in a way the main result, right?
Sorry?
Oh, sorry. That's in a sense the main result, or very interesting result.
Absolutely.
Because it shows there's something on top.
Absolutely.
And
absolutely.
with longer periods. So,
yeah. And what's in a way reassuring is that this is the unemployment rate, and you get the exact type of evidence. I think there's maybe some changes in the magnitude of the R squares, but roughly you get the same type of evidence. And notice also that, but I didn't want to talk too much about it, that like if you just forecast with industrial production alone, in the long run you have negligible R squares, but actually this is the model just with industrial production and SRISK, you will get, decent adjusted R square in the medium long run, okay? Again, this is a sample that analyzes, which is kind of contains the crisis. So I don't know how this would generalize, but at least if you look at a sample containing the last 10 years, this is what you will see. Now, last thing that I would like to do, if the internet permits, is showing you. So, okay, so I think it's more complicated. So I did this website. Should I get paid for it, but I didn't. So, okay, awesome. So let's see if I can get it. Awesome. So now I'm sure you're thinking, well, I really want to know who's systemic today, right? Like who SRISK is blaming. And so basically we've done this website in which you can see wait a second. Okay, here I have to go, I guess. Where you can see, for instance, the rankings of financial institutions implied by our methodology. And so, for instance, as of now, so these are the world rankings. If you want to try to do the same type of stuff on a world scale, we've done some research on that. Of course, you need to deal with synchronicity because different venues have different opening times. You have to deal with some kind of issues like that. But anyway, it's kind of straightforward to carry out this type of analysis on a global scale. And so, for instance, here you get the systemic risk rankings for, I guess this is just for Europe now, I guess. And for instance, you would see that right now in Europe, BNP Paribas, Deutsche Bank, Crédit Agricole, Société Générale, Barclays, Royal Bank of Scotland will be the companies that, as of now, you would consider as most systemic. I'm not going to go through it because it's a bit boring, but actually the site is fairly interactive in the sense that if you want to see for these companies different type of series, like the degree of SRISK, the volatility, the degree of leverage, and stuff like that. You can do that quite easily. Okay, so I don't have time to go through, but anyway, I just wanted to point out that if you're curious to know whether this methodology is able to capture some events that happen in some part of the world, in a way it's kind of easy. You just have to go on the website, click, select for which day you want to see the rankings, and you can see whether the rankings we provide match the anecdotal evidence that you might have over something that happened in France or in Spain or some other part of the world. And I'll conclude here, so thanks so much for your attention.
So let me ask a question just for the fun of it. So I'm doing some stuff looking at, with Alan Berger and other guys, looking at the effect of TARP on not only the TARP receiving banks, but also the banks around. So you have like a metropolitan area, like you could call it a big Moscow, big whatever, St. Petersburg, and then some of the big banks get TARP. And the question is not only what happens to these banks, but also what happens to the banks around them. And there are competing theories. One theory is, okay, it's like a lullaby. People see if things go wrong, you'll be saved anyhow, so we're not going to care about risk anymore, also for the other banks.
I see.
But another possibility is that it's like a wake-up call. Someone is going bankrupt here, so wait, I better watch. And a third possibility is there's some poaching effect. So there's this big guy who gets saved. So maybe the other banks who are actually better and healthier, the depositors make up their minds. Say, okay, I'd rather put my deposits with this big bank because they will be protected.
I see.
So the question is, which one will it be? But what I find interesting about your analysis is that you link the TARP to underlying risk. So my guess would be, if you want to analyze this, the effect of TARP on the banks around the TARP receiving bank would depend on whether the TARP is driven by SRISK or not.
Yeah.
So you could have almost an instrument or something, or a predicted TARP or something like that.
Yeah. So again, well, besides SRISK, but I like to think that TARP was given to those institutions that pose bigger threats in the eye of the Fed, right? This didn't happen always. We have some issues. But so in a way, for us, it's kind of the realized so to us, it makes sense to compare the predicted systemicness an institution has with the realized systemicness as evaluated by the Fed. The issue is that it's not without the TARP, it would be a little bit hard to differentiate the two. Just a small anecdote, a paper I wanted to present, but I didn't have the time, and then we go to lunch. We were looking at stuff in systemic risk and historical perspective using panics from the 19th century. What's interesting there is that there was no deposit insurance. So when clients of banks were concerned that a bank would be in distress, everyone went to actually get the money out, and have really cool pictures from newspapers of gentlemen dressed up with hats and ties in front of the bank in line to get their savings out. So that, in a way, it's kind of you can think of as a proxy of the amount of distress as evaluated by the market. So for instance, actually, in the 19th century data, it's easier to do. But with today's data, essentially the TARP is the best proxy of these kind of objects that we could come up with, so to speak. And there was something else I wanted to say, but I'll say it during lunch maybe. Yeah, sorry.
For the presentation, and with my limited knowledge about banking regulation, I would like to see from the Basel II to Basel III, there's a lot of evolution. And for me, the most essential thing is the liquidity ratio, because it's not only depend on the capital minimum capital requirement, but also the liquidity. For me, the essential function played by banking system is the transformation from usually the long-term capital to the short-term use of the capital. So I want to know if it will be included in the indicators for the calculation.
So I see what you're saying. So I have to think about it. In a way, we don't really do it, but I see what you're saying. So I have to think about how to do that. In a way, we didn't think of that. Let me just say, just a note on that. So this kind of new regulation that kind of limits how much liquidity banks can have makes sense. However, you have to be a little bit careful. There's a nice paper by by Pedersen, in which it shows that if we have kind of stricter capital requirements, I'm pro capital requirements, don't get me wrong, but we have to be careful because if you have stricter capital requirements, if your policy is just to make capital requirements harder, then it's more easy for banks to fill capital shortages when things go bad. So it's not clear whether, there's a debate over counter-cyclical capital buffers for this reason, for instance. And these measures were implemented, they make a lot of sense, but you can also make arguments against, in a way.
Thank you very much for the presentation. Probably it's a silly question, but anyway, you said that it's really complicated to compare these kind of systematic risk measures like SRISK and COVAR you told yesterday. But anyway, do you have any ideas how to sell, for example, your SRISK over COVAR? Especially, it can happen that they show different results, right? For the same company, for example. So how to sell your measure in terms that to give it more credit to the company?
So in the banking analysis that I did in the 19th century, so we did a comparison of different systemic risk measures. It turns out that in practice, these measures tend to have a high degree of correlation in terms of efficiency. It turns out that SRISK from a predictive point of view does slightly better. My only problem is that if I say it, nobody will believe it because I did the previous paper. But I'm being honest to you, like we did the analysis actually from a predictive point of view, at least the analysis we did, we got a little edge on top of COVAR. One thing that COVAR does that to me doesn't make a lot of sense, in the end COVAR is essentially a downside beta times size. And in a way, it doesn't really make, if you interpret what this number is, it doesn't really make a lot of sense. Actually, if I wanted to put it this way, in the first version of the paper, Adrian and Brunemari would just compare banks by looking at the different COVAR. Then we saw that we multiplied by size because otherwise small banks would be on top, and then we added it. So in a way, there were a bit of interactions between the two papers, in a way. And maybe another thing that I would add that makes, at least in my eyes, SRISK more appealing than COVAR is that we also take into account leverage. It's an actual estimate of the capital shortage that the financial firm is going to experience in case of a systemic event. Well, COVAR ends up being downside beta times size, which does not really have a clear interpretation. The first version of the paper, where we're using asset returns, the interpretation of COVAR was on paper nice. But in practice, we were not doing empirically what we were promising to do in theory, so to speak. However, I would say that from the point of view of a regulator, what I would do is, as I was saying before, I just talked about two things. There are also other interesting stuff out there. It's pretty inexpensive to run 10 of these type of models together. So, you get your different rankings from different methodologies. Often there will be a lot of overlap. Sometimes you don't. If you see that there are some banks that are on top, you just send your guys to that bank or you try to get additional information. So I don't necessarily see them as super competing methodology from the point of view of the risk manager. In risk management, you already kind of compute different proxies of risk for financial institutions to monitor what's going on. So, why not for systemic risk?
So if there are no more questions, let's stop here. Thank you very much for the lecture.
Thanks so much.